Dear Professor Parkinson, dear everyone. So it's honor for me to share my research, current research here. So my theme today is like social simulation and empire dynamics. So our current work is focused on this topic. So we have developed some agent-based modeling to simulate social phenomena and as well as the empire, the life cycles of empire in the history. Also, we try to model the evolutionary dynamics of international relationships. This can reveal the pattern of what system in the future. First, I'd like to introduce my personal knowledge structure. So this is very unique for me for the science community. So my major in the PhD is sociology, and after that I had 2-year postdoc experience at the Department of Automation. So my research method is like computational social science or social computing. It's very how to say, it's very interdisciplinary direction. So also I have visited 2 countries such as the USA, like University of Chicago, and also the Korea. They are both 1-year duration. So my first section is modeling collective actions in the real world. So the life cycle modeling is proposed by me in 2016. So this model is very simple, but it's powerful. It can explain the whole whole life cycle process of collective actions. So I will mention this model later. So this model can also be used to analyze empire dynamics in the later section, in the following section. So first, I proposed this model, life cycle model, to simulate online collective actions. So the second section is modeling the online collective action or internet collective actions. So also we focused on the whole process, the whole life cycle process of online events or online cases. So this map, this figure is like we model this whole process into 4 stages. So such as prepare, outbreak, peak, and vanish. So there are 4 stages. And we use the perspective of energy to analyze this process. So for negative energies, so they may be charging into the individuals, and so the individuals with more negative energy, they will express it online. So this is a balance from energy input to energy output. Following this idea, so we divide the 4 stages into 2 stages. So the first is input, the energy, the accumulation of energy, and the second is output. So So we can have the relationships between two strategies. They are equal. They are equal. So the energy input equals the energy output. So we can have this equation. So for the same volume of energy input, there may be different patterns. So like this one, or this one. So maybe this one has a much shorter duration, and while this one has a much longer duration. So they are all possible. They're all possible. So by big data mining, so we can obtain the features of them online. So how to predict the whole process of online collective actions? So we have obtained four parameters. So using these four parameters, we can predict the whole process for any collective actions. So the first parameters is 0.5%. Yeah, this value. So this value indicates the transfer probability. So if we have 1,000 people that see this news, we finally have 5 people, 5 participants. So this is a stable ratio for online collective action. So using this value, so we can predict how many energy have been input for this or for these online cases. So the second parameter is the ratio. So between the peak's timing and the total duration. So this is also a stable ratio. It follows a Gaussian normal distribution. So using this parameter, we can predict what time the peak has been reached. I mean the timing, which day, the timing. So for the third parameters, so it can tell us how high, how much, or how fierce the peak day. So it calculates the volume of the peak divided by the duration. So using these parameters, we can know how high, how much, how fierce the online collective action can be at the peak day. So for the final parameters, so it calculates the curve, the shapes of the curve. So it might be if it's with the standard value, so it would be a triangle. If the value is larger than the standard value, it would be like this one, very fierce all the time. Otherwise, it could be this one, so not very fierce, only be that at the peak days. So using these 4 parameters, we can predict the whole process of online collective actions. Yeah, so we have using for these 4 parameters to predict online collective actions, and we are cooperating with some big data companies to do this. So the other question is how to simulate multiple online collective actions for the internet, for the cyberspace. So the previous previous modeling is used to predict the life cycle of single cases. But we know that they are interact with each other. So we should model the whole system with multiple online cases simultaneously. So we propose the mechanism of online attention dynamics. Using this dynamics design, we can precisely match real-world cases and features. So, so this is the distribution of directions. This is the distribution of direction for the real big data cases. And this one, figure C, shows our simulated durations. So they are very close to each other. So the third section is how to model social events and emergencies like terrorism attacks. So so we can simulate the terrorists with knives. So this is a case for China in 2014. So we can build the basic modeling, basic environment for the railway station, and also we can model the action rules of both civilians and the terrorists. So using this action rules, so we can back calculate the whole process, and we can obtain the curves for any indicators that we feel interested about in it. Yeah. So also we use the case for another case. Sorry, it's not China. It's USA. We can also model the process of terrorist attacks. So in this paper, we distinguish the attack deaths from the stampede deaths. So we can classify the deaths to into two groups, so such as attack deaths and stampede deaths. So in this paper, we can have two number for two sources of deaths. So also we model terrorist attacks for them with guns. So this the case from Pakistan. So in this paper, we introduce the role of heroes into our design. So we can model how many heroes is necessary to stand and fight bravely against the terrorists. So the effective number is 3. So for each terrorist, we need 3 heroes to fight against it. And so this attack can be contained under 3 heroes versus one shooter. So also we also developed some very subtle designs for the agents. So for our agents, we are not simply behaving under certain rules. It's not what we need, not what we want, and it's not real. So for the real world, for agents, they can learn from previous cases. Sorry. Okay. So they are smart. They are smart enough. So they should, or they Actually, they are learning from some knowledge, So in this paper, we try to model this social learning process, like we name it as social learning algorithm. So this process is, I think, is simple. It's very intuitive. For it's not difficult to understand. So for each simulation, we can compare the outcomes. So for parallel simulations, we can obtain the whole structure, the whole knowledge structure. So this knowledge matrix will guide individuals to behave at the next simulations. So meanwhile, the risk matrix will push people to be heroes. So for two reasons, they have to be heroes. And for individual level, they how to be heroes, so they have to cooperate and do some communications, So we design the communication mechanism in this paper, and so if we can design like I, right, like this way, so we can organize potential heroes in the crowd. So in this way, we can more heroes will be encouraged to be real heroes, so the social outcome will be improved, will be better. So yeah, this is the core idea of this social learning algorithm. So the fourth section is about how to model empire dynamics. So we are, for now our target is China in the history. So we should model why this process is so persistent. So in China history, so one empire rise, peak, and decay. Then another empire rise, peak, decay. They do the same thing. So it's very fascinating for me to. So we want to model this whole process, why they are so dynastic, rising and falling in the whole history. Also, so the first we have three methods to model the empire dynamics in Chinese history. So the first one is life cycle modeling. So yeah, obviously, this is we borrow the ideas of life cycle modeling of online collective actions. So at the same time, we add some new parameters, but the fundamental formula is similar. So using the life cycle model, so we manage to simulate the whole process of online collective actions. No, sorry, the whole process of empire dynamics. So we also have some best fitted solutions. So we name them as optimal solutions. So for China history, using life cycle modeling, we can have three solutions within 1,000 simulations. So it's not hard to obtain the solution. So this implies that the history have some laws and regularities, and the history process can be modeled and can be analyzed by our computational models. So also there are some detailed check. So for each optimal solution, so the outcome, the matching degree is acceptable for us. Also, we use this model to explore the history of Vietnam, because the two countries in the history is similar. They are all agricultural empires. The difference is the dynamic cycles in China has lasted for over 2,000 years, while the Vietnam is lasted merely for like less than 1,000 years, but the pattern is similar. So also we can have 3 solutions for Vietnam. This details check. Yeah. So the second method is sampling modeling. So the idea is self-organized criticality. So this means that the system will always running towards the collapse from chaos to order and from order to chaos. So this is the meaning of the sampling modeling. The fundamental idea is that the sampling system and the human system are the same, or they share some common grounds. So following the sampling system design, so we can also simulate the whole history of China. Yeah. Also, this sampling model can be used to other countries. So this is also the detailed check. Yeah, we can obtain the same size of the same number of empires or dynasties in the history. And also to Vietnam, this also it can be used to model Vietnam as well, and the outcome is acceptable. And also we use the third method, like ecological system modeling. So I like this model very much. So because yeah, it's very easy to understand. So we can use the ecological system to analyze the empire, the agriculture's countries. So also for each agent, they have the meanings. So like so in the ground, there are some grass, yeah, that growing each year. So they produce the energy, right? And the sheep will eat the grass and obtains the energy. Then the wolf will eat the sheep, and yeah, they will be growing all the time. And then the tiger is the enemy, right? The enemy of the whole system. Yeah, they will invade the system and eat and destroy the whole system. So for the empire, it has the same logic. So there's some wheat, farmland, some grass, right, growing in the farmland, and the farmers, they're working on it and produce the grass. Then the big portion of the grass, they are transferred to landlords. So from local landlord to the empire, right? So we use the building to represent the system, like the country. So the two system is similar or the same pattern, because the energy, right? They receive the energy. They both receive the energy from the sun, and they transfer the energy from the bottom to the higher level. And for if the empire is weak because of the official corruption or natural disasters, this empire will be weak, So the enemy will invade and destroy the whole system. So the logic is very similar. They have some similarities for the two systems. So following the logic of ecological system, we set four groups of agents. So the first agent is grass, right? The second is sheep, and the third is wolf. The fourth is tiger. To simulate the empire dynamics of history of the empire in history. So for China, we have done this task. So we can we have obtained the big history. Yeah, the curve. We can obtain the highest precise the highest matching degree. So we can back calculate the history from the Qin Empire to the Qing Empire. So the whole process has over 2,000 years. We can obtain the precisely matching curves for the history of China. So also for Vietnam, we can also achieve the highest matching curve using our ecological modeling. So for this section, we can model the civilized patterns for the world. So for now, we focus on China. So China, the pattern is a unity pattern, because this process has lasted over 2,000 years. So for China, this is a cycle. So chaos to order, then to chaos, then order. So this is the chaos time. This is the chaos time in the history. So this is the order time in the history. So it's very this law is very robust and persistent in the history. So chaos order, like this way. So we deem the unity pattern. The civilized China, the civilization takes on the unity pattern. So for other places, there may be disunity patterns. So for now, we are focusing on the China's pattern. So the origin of the unity or the great unity is the Eastern Zhou periods. So this is the origin, and we are focused. We are trying to model this process. We want to answer why the unity process is achieved. So from 168 states to finally one united state, the Qing Empire. So we want to model this whole process of unification. So based on history records, we set some action rules for this process. So the first rule is aliens behavior, and the second is launch wars to other states. So the second rule is the outcome. So if you lose, you will, if you fail, you will lose nine units of blood, such as this, or wealth. So the first rule is betray. If your aliens group is always fails, so you have to change it to another aliens group. So under the 4 action rules, so we can obtain the final outcomes and the dynamic outcomes for each state. So this is the outcome indicator. So if your power for each state, for each state, if your power is larger than 19, so you can be strong ones. So for if your power is 0 or below, so you will die. So we have 4 basic rules to capture this process from multiple states to only one united state. So this is the dynamic video for this process. So it tells us that the war is the primary mechanism for the unification in the history. So from many states to one state. So also so using this like optimal solution, my definition, optimal solution. So we can back calculate the whole history process at each year. So for traditional history research, so it's very hard to calculate, but using computational models, so we can back calculate this whole process at the definition of each year. And also we can explore the conditions and the boundaries of 2 patterns. I mean, disunity and the unity patterns. So we can find the boundary of related factors, so such as this is a, so we define this as the unity pattern, and we define this one as the disunity pattern because there are still many states, so it can't be united. But for this pattern, so the number of states is declining, so this can be unity pattern. This is unity pattern. So we can find the condition and boundaries of some key factors. So if the aliens propensity is beyond like 0.75, so this will be it's very hard to unify the whole country. And for the propensity of for the war propensity, so if we can also find the boundary. So if this value is this war propensity is over like 0.25, so it's very easy. It's very easy to unify the whole system, the whole country. We also can find some boundaries of cost of launching wars. So using computational models, we are able to identify the exact condition and boundaries. So the last section is how to model international or global relationships. So we are planning to use social force model. So the social force model has been used to simulate the crowd dynamics, but we plan to use it to analyze the world system, like international relationships, major relationships in the world, such as China and the US, or Russia and the US relationships. So for this model, we use two forces. So the first one is a repulsive force, and the second one is attractive force. So if the country is if the distance, I mean the global ranks of two countries, they are very close. So the repulsive force will be obvious. So if the global ranks, if two global ranks is they are very far from each other, so the attractive force will be very obvious. So following this idea, we can model the relationships for each pair of two countries in the world. Besides of this, we can also evaluate the constant of coefficient for both repulsive force and attractive forces. So I think we can do it, and we have a clear plan for this, and we are working on it now. So yeah, that's all for my talk, and a very brief introduction. So for 6 sections, and if you have questions, please ask me, and maybe I can. Also, I want to know what are you guys working on. So.